Where did we end the last time? We ended with identify the hydrogen having formula, this much. And so we have done free radical halogenation, electrophilic aromatic substitution, free radical halogenation. So we'll do with alkene hards. Today is very important class. And a few things from 11th standard will also be taught because this is again there in the syllabus. Okay. I think I should start the class now. So till now what we have discussed the method of preparation. And in method of preparation, we saw that we started with alcohols. Okay. And in alcohols, there are a few things that is important. So first is phosphorus-based reagent that you can easily identify what is going to be the product if you look at the reagent. But the important thing is SOCl2. The important thing is Lucas reagent. You will come across Lucas reagent again in the chapter of alcohol, phenols, and ethers. And then the question about reaction of alcohol with Ki. So it will not give you alkyl halide, and then in the presence of H2SO4, it is not going to give you alkyl halide, and that is why we use H3PO4. Okay, so these are the three things that is important in alcohols. Then we looked at electrophilic aromatic substitution. Now in electrophilic aromatic substitution, you have to remember about the electron donating groups and the electron withdrawing groups, right? And electron donating groups will give you O and P isomers. Electron withdrawing group will give you M isomers. Then we looked at the free radical halogenation of alkanes. Free radical halogenation of alkanes. In this case, we have three important questions. The first question will be how many products, how many mono halo products will be formed. Okay. The second question that is important is which of the isomers will give one monohalo product? Which of the isomers will give one monohalo product? Okay. This is another important question. And then the last question, which is also very important, is what is going to be your major product, right? What is going to be your major product? That is also an important question. So till now we have learned this much, and see, these are all the questions that can come. So you can see 1, 2, 3, 4, 5, 6, 7, 8. At least these are the important questions that you can come across in the small topic, and that is also incomplete topic of method of preparation of haloalkane and haloarene. So in today's lecture, we will look at the third way in hydrocarbons. Let me write it C, and let us write from alkenes. Okay, from alkenes. Now, in alkenes, we will start the reaction with, please write number 1. Halogenation of alkene. Okay, halogenation of alkene. So please write, when alkenes are treated with halogen, they form dihaloalkanes. Dihaloalkanes. That means if you have something like this, C double bond C, there are two different groups attached to the carbon atom, and you react this with X2. That means you are going to get carbon. The two groups that were attached to carbon, they will be as it is, and you will be attaching X here and also an X here. Okay. So this is the general scheme of reaction that you can have in halogenation of alkene. So please write this down. Let me know when you're done. All right. Now, also note alkyl halides with halogen atom on adjacent carbons are called vicinal dihalides. Okay, vicinal means that they are in vicinity. Huh? The halides are in vicinity. That means they are neighbors, and this X group is a neighbor of this X group. Okay, and generally in this case we use Br2. In this case we use Br2. Also, right? Bromination of alkenes bromination of alkene. Now, bromine, it has a kind of reddish brown color, and when you are treating it with alkene, what is going to happen? It will form vicinal dibromide, and this vicinal dibromide is going to be colorless. So you are going from color to colorless. That means what can we use? We can use this particular reaction in order to test for alkenes. Bromination of alkenes is also used. You can write is also used as a test for presence of double bond. Okay. So you have alkene plus Br2. This Br2 is reddish brown. When it reacts with alkene, what happens? It will give you vicinal dibromide, and this vicinal dibromide is going to be a colorless element. It is going to be colorless. Please write colorless here. Chen, is this clear? Yes or no? Please tell me.
Yes, sir.
Now write some reactions.
Sir, do we have to send in the group or personal?
No, you can send me in person only. Group is majorly for example, if I have to send all of you something, some important thing, then I will send it. Hello. Okay, Samira, I have received yours. डबल बॉन्ड नहीं तोड़िएगा क्या समायरा? हाँ, see the double bond gets broken ना?
Okay, sir, I'll do it.
हाँ. Oh, sir. Okay, fine, sir. Don't worry, you just wait for a while. Meanwhile, you write this. Saf, you write this.
Okay, sir.
This is Khalid. I have your number. Don't worry. No, Khalid. First one is wrong. See the number of carbon atoms. You have messed up with the number of carbon atoms. Whenever you see a new reaction, please keep in your mind the bonds broken and the bonds made. In this reaction, what will happen? The pi bond breaks and CX sigma bond and CX sigma bond forms. Now it is correct. Khalil. Yeah, very good, Khalil. Correct. Matthew. A is correct. B is correct. No, A no. B and C is correct. A, I don't know what you have done. I will show you. Hishma, do you have my number? Waiting for Hishma, Salman.
Yeah, I sent it to Nishkash, sir.
Yeah, send it to Nishkar, sir.
Yes, sir.
Nishkar, to Learnivio.
Yeah.
You don't have my number or what?
No, sir, I don't have.
So you're not a part of group?
No, sir.
Oh, okay, fine. Then I will ask them to add you. But no, you just send a message to this number, then I will add that number on the group. Okay. So just WhatsApp your answer to my number,
Okay, sir.
and then I will add you on the group also. Yes, Khalid, the first one is not right. See what you have done. Just look at the number of carbon atoms. Either you have made that bond very small, so I can't figure out. Draw all the bonds properly, huh?
Sir, the second one and the third one is correct.
Second and third is correct.
Okay.
Perfectly. Maybe you have drawn the sigma bonds very small for Br in the first case. That is why I'm getting confused. I don't know. Saf, let me know when you have written it.
Yes, sir. Finished.
Finished. Now, can you attempt these questions? Can you see what happened in the reaction? And then write the answer. Tell me.
Okay, sir.
Anna, you saw, right? What happened? You just need to break the pi bond. And instead of pi, you have to write the x. And the x is Br2 here, right? So
Okay,
not,
sir.
it's a no-brainer type of thing.
Sir, you're
Okay.
the one who sent that syntax error, right? That number.
Sorry?
You're the one who replied for the syntax error for the PY code. And then,
Hi.
yeah, okay. Okay.
Correct. Hishma, this is your number. And I think this is your number. Yeah, correct. It's your number. You're not on the group. I will add you on the group also. Wait a second. So, waiting for your answer, Saf. Okay. I think everyone has sent me answer, right? Got Khalid, Matthew, Khalil, Samaira, Salman. Okay, Hishma has also sent. Hishma. So Matthew is also sent. Okay, just waiting for Saf's answer now. Now, others, you may try this one. And this is important. Acha, Saf, if you have done the first one, first and second one, can you please send those? If you're right for the first and second, then you will be right for the third one also, I think. Oh, very good. See, you can make the product. Very good. I hope others are trying for the fourth one.
Should we send that to him?
No, see, you made the line very small. See, Saf, how you, sorry, not Saf, Khalid. Whenever you are drawing the product, you have to, or okay, this is for everyone.
Sir, did you receive mine?
Who is this? Matthew.
Sir, I didn't send my.
You have sent, no?
Yeah, the first one I've sent, but not the fourth one. The first three
Not the,
I've sent.
first thing, okay. Khalil, where are you asking? Khalil, I have received yours also. Who was asking? I think Khalil was asking, no?
No, sir, I didn't.
You didn't ask. Who asked them? I have received everyone's. Okay, first three I have received everyone's. Now, all of you, please listen. Whenever you are drawing product, then what you have to do, identify the bond which is going to break. So this pi bond is going to break. So you write everything other than the pi bond. Okay. So now this is the structure. Then you add the bond which is going to form. So Br is going to form like this, and the Br is going to form in the other carbon like this. Here also, you draw the structure without the bond that is getting broken, and then you add the Br here, and then you add the Br here, right? Also, one more thing that you can do is you can map the 1, 2, 3, 4. So many people do it like this. They write the complete molecule in 1, 2, 3, 4. So you draw all the 1, 2, and 3, and 4. So you saw that second and third carbon are getting bonds broken, and here only we are going to add Br. Okay. So anyone who attempted the fourth one, raise your hand. Anyone who attempted the fourth one? Okay, Salman has attempted. Send the answer, Salman. Okay, Khalil, send the answers. Whoever has attempted, send the answer for the fourth one. Correct. Khalil is correct. But both of them are same molecule, right, Khalil?
Yes, sir.
Waiting for Salman's answer. Yes, Salman.
Yes, wait a second. My phone's slow, so.
Acha, okay, fine. Okay. Khalid has also sent me an answer. Okay, fine. Okay, fine. Now see, we have to look at the reagent. Huh? So what is the reagent? Br2 and H. Yes or no?
Yes,
Correct?
sir.
Okay. So what is H nu? This guy. It is a, what did I call this? Remember last lecture? What is this? These are radical generators. Correct? Yes or no?
Yes.
So that means it will generate radical, right? It will generate radical. That means what we are going to have? We are going to have a free radical. And you may say that this is an alkene, but also please remember that there are carbon atoms such as this carbon atom, and then we have this carbon atom and this carbon atom, which are having single bonds, and there are CH bond also connected. Is that right? Yes or no? Please tell me, all of you.
Yes,
Can all of
sir.
you see that? Right.
Yes, sir.
Now this carbon is sp3, and since this carbon is sp3, what is going to happen? It can show free radical halogenation of alkane, because this carbon will be showing the properties of alkane. Only this part is alkene, right? And the reagent is what? Reagent is appropriate for free radical halogenation. Now you can either have a radical. Now, as you can see, the blue carbons and the red carbons are same. Is that right? Yes or no? Please tell me. The blue carbon and the
Yes,
red
sir.
carbon is same.
Yes, sir.
You all can see that, right? Okay. That means either you can have a free radical here, or you can have a free radical here, right? There are two different, either the blue case or the red case. So you may have it something like this, a free radical, or you may have something like this. You may say that both of these will be generated, but which will be major? Tell me, A or B? What do you think, guys? Which will be major? A or B?
A because of symmetry.
A because of symmetry. What kind of
Yes. No,
symmetry?
no mind. There's something like that.
Yeah.
I remember. Okay.
Something like that. Okay. So actually there is A double bond B and single bond C with a free radical. So this is the condition for what? Tell me. How many of you remember A double bond B, single bond C, and resonance? Okay, sorry, I said the answer. And the free radical. It is a condition for resonance. Yes or no? Please tell me. I hope you guys remember now. Hishma, Khalid, Matthew, Saf, Salman, and Samaira. Oh, yes or no?
Yes, sir.
Yeah,
Okay, what about others? Hishma, Samaira? आप लोग को आया?
Yes, sir.
Yes, or was it too fast? Should I go over it again? Hishma, tell me.
No, sir.
No. Okay. Samaira, what about you?
Yes, sir.
You remember it, right? Resonance. Okay. And that is why this is going to be our intermediate, which will be more stable, and that is why we'll make a product further on like this. And can you see that the double bond is untouched? There is nothing happening on the double bond, so this double bond will be as it is. and you will get a BR here. Okay, you will get a BR here. Okay, so please write this one. This is very important. And at the end, you will also write something like this. If you have some alkene type of thing, and there is Br2 plus H nu. If you have only Br2, then if you have Br2 plus H nu, then you are going to do free radical halogenation. The Br will be here. And if it is only Br2, that means it is going to give me vicinal dibromide. Br here and a Br here. Tell me, please write this down. Let me know when you're done. Is everyone done?
1 minute, sir.
Yes.
चलिए. Should I move forward? Yes or no? Please tell me. Saif, आपका हो गया?
Yes, sir.
Okay. Now, right, the next method of preparation. So the first method using alkene. Next method is using hydrogen halide. What are hydrogen halides? Hydrogen halides are HX. Okay, so you will have things like HF, HCl, HBr, HI. Okay, Salman. Okay, so these are hydrogen halides. So please write. When alkenes are treated with hydrogen halide, they form corresponding alkyne halides. They form corresponding alkyne halides. So the reaction is carbon double bond carbon plus HX so here one of the carbon will get hydrogen and the other carbon is going to get your halogen atom. This is going to be your product. Chalo. So in all of these cases, you can see that the double bond will get broken. One of the carbon will get hydrogen, and the other carbon is going to get your bromine. Okay, the halogen atom. This is the simple case. The simple case. You write the examples as well as their definition. I hope you have written the statement using hydrogen halide. Done everyone, yes or no? Please tell me.
Yes, sir.
No, sir. Just seconds, sir.
Okay, fine.
Done, sir.
Okay. Now, let us see what is going to happen if I have something like this. CH2, double bond CH, single bond. Wait a second. Don't write, okay? Don't write anything. Write like this rather. CH3, single bond CH, double bond CH2. Okay. Now, if I will add the HBr here, I'm going to react this with HBr. Then there are two different products that can be formed. In all of the above case, there is only one product. If you write even if you add the hydrogen here or here, and the Br here or here, wherever you add the Br, it doesn't matter. You are going to get the same product, that is bromoethane. Here, whether you add the chlorine in this carbon or this carbon, you are going to get always 2-chloro 1, 2, 3, 4 butane. Okay, if you add the bromine either in this carbon or this carbon, you are going to get bromo. Or 1 bromo, you can write 1 bromo cyclopentane. Okay, it doesn't matter whether you are adding the Br, but when you have all of these are examples for symmetrical alkene. You can see that the number of carbon atoms on the left as well as the right of the double bond is same. Here also, if you look at the number of carbon atoms on the right and the left, they are same. Here also, if you draw a symmetrical line like this, then you can see the number of carbon atoms there and number of carbon atoms here, they are all the same. But when you look at this unsymmetrical alkene, this unsymmetrical alkene is having 1 carbon on the right and the left has 2 carbons. That is why it is going to give you a problem when you are going to add the H and when you are going to add the Br. Let us say I will add CH3, CH, and I added the hydrogen in the second carbon and I added the Br in the third carbon. So this can be one case. Plus I can get another case which will be CH3. Now the CH second carbons get the Br and the third carbon CH2, it is going to get your hydrogen. Okay. Now in this case, we have to first of all look at the mechanism and tell which is going to be our major product, Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay, fine. So now we will look at the mechanism. Now, in mechanism, let us look at the first step of mechanism, in which I have CH3, CH, double bond, CH2. Now, and then we have HBr, right? And this HBr will have a delta negative on the Br and H positive and delta positive on the hydrogen atom because Br is more electronegative. And then we have the pi bond. Now this pi bond is what? It is electron rich. It is an electron source. There is a high concentration of electron in the pi bond because there are 4 electrons. Now where here you are having electron rich source and there is hydrogen which is electron poor. So there will be a transfer of electron like this. And what is going to happen in this case? Now either this carbon is going to get your hydrogen or this carbon is going to get your hydrogen. So let us make both of these products. So let me make the blue product first. And let us see what will happen if I add the hydrogen on second carbon. I have CH3 followed by carbon CH and the hydrogen is in the second carbon and then the CH2. Now, since we have added this pi bond and hydrogen is attached on the second carbon, this CH2 is going to get a positive charge, right? Now, if I look at the green one, then what is going to be the product? CH3. Now, these are the things. Now you can write the green one, yes or no, please tell me. What is going to happen if I add the hydrogen on the third carbon? Tell me, all of you, Hishma, Khalid, Khalil, Matthew. If I have drawn the first one, you can already draw the second one also, yes or no? Samaira?
Yes, sir.
Yes, sir.
right? And try it now. Try it. That is what I want. Okay. I want you all to recognize the pattern, how things happen. Chaliye, you write what is the intermediate that will be there if the hydrogen is added on the green carbon. So this pi bond will break and this carbon is going to get the positive charge. Chaliye, खुद से बनाइए and then send me a photo. Okay. Draw the structure and send me a photo. Do other also ask for photos? या हम ही परेशान करते हैं आप लोगों को? I hope I'm not the single one. हाँ समायरा?
Sir, only you.
ओहो ठीक है आप लोग कुछ बददुआ मत दीजिएगा परेशान करके उससे तालीम से. But it is needed actually. It may be not needed. I don't know. And I only ask in organic chemistry because I want to see how you're drawing things. हम हमेशा नहीं मांगते हैं, ठीक है? Saf has sent me. Very good, Saf. Very good. I'm waiting for others now. Khalil has sent. Khalil, I think you missed the positive charge, right? In the second carbon. Or have you
Yes.
drawn up? Just draw. Everything else is fine. No problem. Don't worry. Everything else is fine. Khalil has sent once again. Now it is perfectly fine. Samaira, can you turn the mic on?
Yes, sir.
Okay. So the third carbon is getting one hydrogen extra, right?
Yes, sir.
So it earlier had how many hydrogens?
Oh, two hydrogen. It will be
Two
three.
hydrogens. And also one more thing. Whenever you're drawing the bonds, you don't draw from hydrogen to hydrogen. You draw from carbon to hydrogen. ऊपर वाले में भी आपने वैसे हाइड्रोजन से बॉन्ड बनाया है, right?
Oh, yes, sir.
Okay, so the bond is with carbon, not with hydrogen. So some teacher, they may cut the marks. Even though these things should be neglected in your standard, but still take care whenever you can. Okay, Matthew has sent me an answer. Yes, Matthew, very good, correct. Waiting for Khalid. And Hishma has not sent me an answer. Hishma, Khalid and Salman. Okay, Samaira has sent me one second. Achha, theek hai, Samaira, it's fine. You can directly write it CS3. Fine. Correct. सैफ समझ में आ रहा है आपको?
Yes, sir.
Okay. What? Okay. Khalid and Salman, what happened? Salman said he will be. हाँ सैफ आपने तो भेज दिया. I know. I have seen. You were the first one who sent. Now all of you
Yes,
have
sir.
done very correctly that it is CS3 followed by CH, and this carbon will get a positive charge followed by CH2, and this carbon is going to get your hydrogen. So see, if you will see me, I try to always draw the structure as it is. I break the bond, and after that I add the bond. Okay, so carbon hydrogen bond. Now you have to tell me, since this is 1 degree carbocation and this is 2 degree carbocation, which will be more stable, 1 degree or 2 degree? Which will be more stable?
2 degree.
2 degree will be more stable. All of you remember this? Yes or no? So we'll
Yes.
write this. This is more stable. And if this is more stable, then means this 2 degree carbocation will be very easily formed, and this is going to give your major product. This is going to give your major product. Okay. Yes, okay. Yes, Khalid, correct. Very good. Okay. Now the second step would be CH3 followed by CH positive followed by CH2. Now I can write this directly CH3, and you will have a Br negative that will be coming, plus Br negative, because here what will happen? The Br will take the bond. This bond will be broken, and Br will take the electron because it is more electronegative. So the Br negative that is already there in the mixture, it is going to attack on which carbon? On the carbon having positive charge. And can you all write the product on your own? Tell me, yes or no? I hope you guys can write, right? Just need to add a Br. You just need to make a bond between carbon and bromine with the second carbon. Okay, try to make it. Just raise your hand when you are done. No need to send the answer now. Just raise your hand. Okay, Saf is done. Samaira is also done. Sally. I think most of you are getting it done. So I hope all of you must have drawn it like this: CH3, CH, and the Br is going to be the second carbon followed by a CH3. This is going to be your major product. This is going to be your major product. Okay. So now you all can lower your hands. So now we have got our major product and the minor product. So this is going to be our major product. This is minor. And this one is our major product. Okay, so just write this down. HBr also. So whenever we have unsymmetrical alkene, that means we have different number of carbon atoms on the right and left of double bond. And we have unsymmetrical reagent. That means there is a positive charge and a negative charge in the reagent. When we have unsymmetrical alkene and unsymmetrical reagent, then the negative part of the reagent, that means the Br negative, the negative part of the reagent is getting added on which carbon? The carbon, that doubly bonded carbon atom, which is having lesser number of hydrogen atoms. And this is known as Markovnikov's rule. Okay. So even though, please remember that Markovnikov rule is not the basis why we are getting major product this, but Markovnikov rule is a conclusion of the mechanism. Mechanism is more important, but Markovnikov rule is important in terms of examination. Okay. Since all of you have written this, you will write Markovnikov's rule. Any guess? Where was this guy from? From which country? Any guess?
Russia.
No, very good, Russia. Markovnikov's rule. So Markovnikov said that. Now, he just observed it. Okay, when unsymmetrical alkene is treated with unsymmetrical reagent, then the negative part of reagent is attached to that doubly bonded carbon atom which has lesser number of hydrogens. है ना? That means if you have something like this, CH3, ऐसे एक काम करते हैं. Okay, so now this carbon will have one hydrogen. This carbon, it already has 4 bonds. That means it will have no hydrogen. So if you do HBr, then out of these two, second carbon is going to get your bromine. Okay, second carbon is going to get your, and the double bond is going to get broken. These are CS3 and CS3. So please write this down. Let me know when you're done. देख लिया आप लोगों ने? Is everyone done?
Yes, sir.
Yes.
Yes.
Sir.
Okay.
Yes.
Then write anti-Markovnikov's rule. So let me tell you one thing what happened actually. Okay, let me tell you a bit of chemical history. So Markovnikov, and there was one more guy, his name was Kharash. So I think they both were working the same university, but in the same department also, but their labs were different, I think. And Markovnikov, what he saw that if he's doing some kind of reaction, he's doing this halogenation. So he said that if I have something like this, and I mainly get two major products. If I do it in day, then I get something like this. But if I do at night, then I get something like this. Okay. So this was his observation, and obviously they all the scientists now also, and in the earlier times also, they have some kind of lab notebook or lab journal. Like we have our daily journals, they had lab journals in which they recorded all of the observation and all of the syntheses they did, all of the products they formed and everything. Now, this was some kind of mystery to him. When he was doing something on the day, he was getting this as the major product, but when he was doing it at night, it was getting this as the major product. So initially he started this reaction in the night and he was only getting this product, and that is why he gave the Markovnikov rule. But when he started doing the same reaction in daylight, what happened? He got some different product. And once Kharash, he asked for the lab journal of Markovnikov. Now again, scientific community, they're kind of open if you are in the same department in the same university. They are not very open if you are in some different countries and you are having some kind of conflict. So obviously those scientific communities, they are not very open, but at that time they both were in Russia, and Kharash observed this, and then he said that, okay, fine, I will try to find out the mechanism. And from there, since the observation was still from Markovnikov was the one who did the experiment, but Kharash was the one who kind of found out the mechanism and all. So this rule is named after both of them. It is known as anti-Markovnikov's rule, and it is also known as Kharash effect. Okay, so both of these names are there for this rule. So please write this with me. I'm turning my mic off. You can just read the lines what I'm writing, and then you can write. Chaliye. Please write this down. Let me know when you are done. So we will do the mechanism in the next class, but today you will practice with the products. Okay. So when you have peroxide or light, or when you don't have peroxide or light, and this is only true for this case is only true for HBr, not for any other hydrogen halides. Okay. So peroxide effect or the Kharash effect is only for HBr. Actually, the HBr bond, it is very long, and the HBr bond can be easily broken by sunlight or peroxide. HCl bond is a kind of strong, and it does not give you, what I can say, measurable yield of haloalkanes. So if it is, it is reacting, but it is not very much useful in the labs and all. That is why we don't write it. So HBr is the only one which gives you Kharash effect or the peroxide effect. Write this down. Let me know when you're done. Then we will do some questions. So I hope you can see the difference between the examples, right? In the presence of light, or here you can write or peroxide also, or peroxide. Salman, are you back?
Yes, sir. I am.
Achha, you're back. Okay, fine.
I was back since a long time.
Long time. Okay. So was I right about the syntax error?
Yeah, you were like the double commas were missing. Sir?
Yes, sir. Tell me.
Yeah, the double commas were missing. He put one comma.
Even one quotes. No quotes were there. Yeah, correct. Also, by the way, now since you have my number, if you guys have any difficulty in Python also, then you can send me. Okay. Even we can discuss some Python after the class if you have any doubts and concepts. Except but for oops. Okay. I'm not very comfortable with oops. Do you have oops in Python in this standard classes?
I don't think so.
So you don't have to make classes and all?
No, we didn't still reach the part yet. So
you haven't reached the part yet. Okay. Fine. Anyone else who has Python in this class?
Sir, I have.
Here.
You have? Khalid also has. Okay. Hishma, क्या चल रहा है आपके स्कूल में in Python?
So we finished Matplotlib.
MATLAB?
Matplotlib.
अच्छा, Matplotlib. Okay, fine. Matplotlib. Is everyone done? I hope everyone is done, right? Yes or no?
Yes, sir.
Okay, fine. Let's do some problem fast, and then we will do the test on abnormal molar mass. Okay. Please write a question. Oops. See, the emphasis on the major product. Okay, you just have to give me one product, nothing else. So if you have a symmetrical alkene, then it doesn't matter where you are going to put the hydrogen and the chlorine. So I think this is relatively easy. So see, I'm drawing for the first one. Okay, I'm drawing for the first one. See, I can attach the chlorine either in the first carbon also and the second carbon also. Okay, so you draw the product like this and then send me on WhatsApp. So you have 3 more questions. So you'll get 3 more minutes. Okay, jaldi kijiye. All of you must have done the. All of you must have written the question, right? Yes or no?
No, sir. Can you show
Yes,
it
sir.
again? 1 second.
One more.
1 second. 1 second.
Yeah, sure.
Yeah. Okay, sir. Yeah. Okay. Go.
Okay, so once you're done with the questions, then I have posted one small question in the chat. You can just answer it as yes or no. Okay, I've got answers. Okay, Salman.
So 8:30 to until what timing?
I think it will be from 8:30 to 9:30 to 10, somewhere between 9:30 to 10 it will end. Okay, so listen, those of you guys who have answered this. What about Khalil? Khalil and Hishma. Acha, listen. For the first question, I can add the chlorine anywhere. Second question में बताइए. Will there be Markovnikov or anti-Markovnikov? Tell me, guys, Markovnikov or anti-Markovnikov?
Anti-Markovnikov.
Anti-Mark. Very good, anti-Markovnikov. So, it will attach on which carbon? First of all, what you will do, you will draw the substrate as it is, and you will break the double bond. Now you have to tell me whether the Br it will attach on first carbon or second carbon. Tell me, guys. First carbon or second carbon?
Second carbon.
Achha, if it is anti-Markovnikov, then it is going to be more hydrogen or less hydrogen. It will attach on the carbon with more hydrogen or less hydrogen. Tell me.
More.
More hydrogen. So, how many hydrogens are here in the first carbon, Khalid? Tell me.
2.
नहीं, number of hydrogen is equal to 4 minus bonds ना, याद नहीं है क्या? कितने bonds हैं इस कार्बन के पास? कितने bonds हैं? यहाँ पे बताइए इस कार्बन के पास कितने bonds हैं अभी? अरे what happened? Okay, anyone else tell me how many bonds does the first carbon has?
3.
3.
3. So how many hydrogen will be there?
1.
1 hydrogen will be there. Okay, fine. And how many hydrogens will be there in this carbon, in the blue carbon? How many bonds does it have? How many bonds does it have?
4.
4. So it will have 0 hydrogen, right? अब बताइए, where do we have more hydrogens?
In first.
1.
So where? So the Br will attach on first carbon. ये 1 2 जो है ना, ये 1 2 it is not the number of hydrogen. Okay, it is the, I have just labeled it as one carbon or the second carbon. चलिए. In the next one, tell me. Markovnikov, anti-Markovnikov. Markovnikov or anti-Markovnikov?
Markovnikov.
Markovnikov. So in Markovnikov, it will be having more hydrogen or less hydrogen?
Less.
Less. तो बताइए फर्स्ट कार्बन सेकंड कार्बन में कौन से में लेस होगा?
Second.
Second.
Second, right? So you will just add a chlorine here. ठीक है? सैफ आ रहा है आपको? सैफ?
Yes, sir.
आप इसका बताइए सैफ, tell me for this one. In this what I will draw everything as it is except the double bond. Okay, except the double bond. Now you tell me it is Markovnikov or anti-Markovnikov?
Anti-Markovnikov.
Anti-Markovnikov. That means more hydrogen should be there. The Br
Yes,
will
sir.
attach on more hydrogen. So you tell me this first carbon and the second carbon, how many hydrogen is there in the first carbon? Look
1
at this and tell
hydrogen.
me. 1 hydrogen. And the second carbon, how many hydrogens are there?
2.
So the Br will attach on first or second?
Second.
Second. Okay. So it will attach here like this. Please write this down, all of you. Khalil. Khalil,
Yes, sir.
आप थोड़ा हड़बड़ में रहते हैं क्या?
Yes, sir. The third question.
Everything is very fine. I'm really happy, but you know, it's okay. Okay, just take care of these things in examinations. The only thing that I care about is कि regret नहीं होना चाहिए. ऐसे mistake होते हैं ना, then बहुत अफसोस होता है फिर. Yes or no, Khalil?
Yes, sir.
हाँ, सब कुछ जानते हुए भी गलती हो जाती है. ठीक है, जस्ट टेक केयर. अगर लेकिन हो गया ना तो फिर कोई बात नहीं, टेंशन नहीं लीजिएगा. ठीक है, जस्ट टेल योरसेल्फ नहीं हमको कंसेप्ट आता है. एग्जाम में अगर हो गया, जब हो गया गलती तो कुछ नहीं कर सकते, राइट? है ना? बट राइट नाउ यू जस्ट नीड टू फोकस. चलिए ठीक है. सो स्टॉप शेयरिंग द स्क्रीन फॉर अ व्हाइल एंड आई विल जस्ट पेस्ट सम क्वेश्चंस. जस्ट टेल मी वन थिंग. कैन आई गिव यू सम क्वेश्चंस फ्रॉम osmotic pressure and reverse osmosis, this type of things? Tell me, guys. No. 10, 8. Huh? What happened?
Fine from my side.
What about others?
It's fine.
Fine ना? और abnormal molar mass से ही देना पड़ेगा, tell me. No, right? Osmotic pressure also, it comes under abnormal molar mass, right? Yes or no? So I think you guys will be fine with it. Huh? Khalil, Hishma, Samaira,
It's fine, sir.
fine na? Actually, if I give you only from abnormal molar mass, it will be completely numerical part, right? But I want to see your writings also. Like how are you writing theory questions and all. B. Wait a second, my OneNote is making some problems. Oh, and Saf,
Yes.
Saf, I don't think you have attended the abnormal molar mass lecture, right?
No, sir. Osmotic pressure is not also not completed for me.
Okay, fine. So you may just write these questions. Okay. Don't send the answers and all. And once you have written this questions, then you can leave. Okay. Fine.
Okay, sir.
Also, wait a second. What I will do now, I will share a video with you. Okay, in which there is osmotic pressure and abnormal molar mass, both the things. I was supposed to do this early, but I forgot. Okay, sir. Did you receive the lectures?
Yes, sir.
Okay, fine. So you can watch them, okay, and then you can try attempting these questions after that. Okay. In those also, I have done similar type of questions. There are slight differences in the data and the molecules that I have taken, but try to watch and do these questions. Will that be fine, sir?
Yeah, okay, sir.
Okay. Let me know if you have any doubt. We will be meeting on Tuesday, so you have some days. है ना? Even if you don't write the notes, then just watch the lecture and you will get to know that you are understanding or not. ठीक है, sir?
Okay, sir.
Okay, fine. Thank
Thank
you.
you,
Bye
sir.
bye. Take care. You guys have 15 more minutes. Okay, you guys have 15 more minutes. Oh, Salman has sent the answers already. Okay. Salman, were you able to do the second one?
Somewhere. Yeah, I believe it's correct.
Second one. Okay. And if you're done, you can leave then. We will see, Salman. I saw your answers, by the way. We will see. Oh, okay. Is that so? Okay, okay. Yeah, we had similar questions in the class also, by the way. Instead of benzoic acid, there was phenol, but it was very similar. Okay. If you want to leave, Salman, then you can leave. Okay. Salman has left already.
Sir, done. I sent you the answers.
वो PDF नहीं बनाया आपने. Khalid, can you make a PDF and send me?
Okay.
Okay. The photos it may get here and there.
Sir, I sent you now
Ah,
the PDF.
yeah, I got it. Thank you, Khalid. Thank you very much.
Okay, sir.
Okay,
Thank you.
Allah Hafiz. Assalamu alaikum. Samara, I received yours also. You guys have 4 more minutes. Ishma, Khalil, and Matthew.
Yes, sir. Scanning, sir.
Okay. Okay, Matthew, I have received yours.
Okay, sir. I can leave, right?
Yeah, you can. Thank you.
Thank you,
Bye-bye.
sir.
Ishma, I have received yours also. Khalil, just waiting for you now. You have 1 more minute. Then the time will be up. Then you have to scan and send the answers.